Hello, ladies and gentlemen. Root Beer here, looking at question number 11 on part one of our Alberta High School math paper. ABCD is a quadrilateral with AD equal to BC and AB parallel to DC. It is only given that the lengths of AB and DC are 20 and 15 centimeters respectively. Adrian puts n copies of this tile together so that the edge BC of each copy coincides with the edge AD of the next. And the edges of DC of all copies together form a regular n-sided polygon. The value of n is. Now that seems kind of vague. They even say the only given information. So you might be tempted to say not uniquely determined, but who knows? Who knows? I mean, it's there, but of course none of these was there in the last question. We didn't use that. We got an answer of, it was 42 for the last one. Yeah, it was. But you know, just because it's there doesn't mean you have to use it. But we'll see. We'll see. Maybe it's possible to have an octagon and a dodecagon that do this. Who knows? Who knows? Well, we're gonna know. At least I hope we will. Okay, so what exactly is going on here? We've got parallel sides. And I know this length is the same as this length. Is that what we've got? A, B, C, D. Right? And AB parallel to DC, 15 and 20, and AD and BC are 15, 20. And DC is forming the outside of my not pentagon, my polygon. Okay. So what in the heck can we say? So I don't know what these lengths are, but it is a trapezoid, so we might be able to, drop a height here. I'll know this is 15. Maybe call this A. This will be 5 minus A. Now, whatever this side length here is, it's x, and x squared has got to be h squared plus 5 minus a squared, but x squared also has to be h squared plus a squared, so it's got to be a nice symmetric trapezoid. So 15, 20, and each of these is going to be a 2.5. And this is a 15 in here. The whole side is 20. But I don't necessarily see that helping. Okay, so what exactly is it that they're doing here? Trapezoid here, but then trapezoid here, trapezoid here, trapezoid here, trapezoid here, trapezoid here, and so that's the sort of thing that they're doing here. And that's what they're doing. And they've got an n-gon, a regular n-gon. Well, of course they do. It's 20, it's 20, it's 20, 20. Right? And then, of course, you get a smaller one on the inside that's all 15s. But what can we do here? Well, how do you know what sort of an n-gon that you've got? Well, angle here helps you out, right? If I have a triangle, a regular triangle, internal angle 60 degrees. If you got a regular quadrilateral, internal angle is 90 degrees. Regular pentagon is 108 degrees. Okay. The interior angle, the way to figure this out, extend all of these. You'll get the same external angle. You'll get 5 copies of it, but you'll have gone around a circle once. So it's going to be 180 minus 360 over n is your individual angle. 180 minus 360 over 3, 180 minus 120, that gives you the 60 here. Okay? So that gives us the angle there. Now, for our trapezoid, we're looking at something that looks a little like this. Now the interior angle here should be 180 minus 360 over n, but This is h, this is h. This is the same number here. This is the same value here. So whatever it is, we'll just call it dot. So that's got to be 2 dot. But then we also get 180 minus 360 over n up here for the smaller inner triangle. And so outside of it, you'll have a 90 degree, a 90 degree, and then 90 minus this dot. And so this should be, so the outside angle should be 180 plus 360 over n. Because if you add those, because if you add these two up, this angle and it's, gosh, is that the reflex angle? Yeah, I think that's what's called, reflex angle. They should add up to 360. Well, these two parts will cancel out and you'll get the 360 you need. So this should be 90, 90, 2 more 90s minus the 2 dots. So that should be 360 minus 2 dots. Well, then that's fine. That doesn't seem to be a problem here. So is there something involving the 20 and the 15 that we have to use? And it might be that this isn't unique. The 15 of the... So if I take... Now, obviously, we can't make a square with these. But can I make, say, a hexagon? Well, yeah, just go in here and then connect those. And as long as I can go in 15 and 20, then yeah. So you should be able to do it with whatever shape you want. I mean, the answers that they give are all even. But if I take a pentagon with side lengths 20, a pentagon with a smaller one inside, so that they both have the same centers, you get the same lengths here, 15, 20, and these should be, assuming everything is nice and centered, this is parallel to this, 15, 20, you should be fine. So unless we're missing something, the answer is not uniquely determined. A, B, and D, C are the ones that we know the lengths of, so yeah, I think we're done then. If it was something like BC that was 15 centimeters, like if you knew for a fact you had 20 here, and these were both 15s, then because you'll have to have the same heights here, you might get something else. But no, it looks like you can just always do this. Take an n-gon of side length 15 and put it inside an n-gon of side length 20. They're centered, and so that their sides are parallel. You'll get the 20, you'll get the 15, and you'll get the trapezoid. So yeah, the answer should be E, not uniquely determined. All right, that was interesting. Yeah, so there we go. Question number 11. It took me a little longer to make myself absolutely confident, because you don't want to just jump for you're not uniquely determined, because then what you're really saying is, well, I can't quite see it. Maybe there was something that made it 12, but no, I convinced myself that, yeah, you can do this with any polygon you want. Break it up into trapezoids like this. And so, yeah, we're good to go. All right, so up next, question number 12. I will see you for that in the following video. Take care and have a wonderful day.